Hi, hello my dear children. I hope all of you are staying safe. In this session, we are going to continue chapter 2, polynomials. In the polynomials, first we have learned what is the meaning of, that is the geometrical meaning of zeros of a polynomial. And we are going to continue on the chapter with the relationship between the zeros and coefficients of a polynomial. Let us see what is the relation between the zeros and coefficients. So, already we have studied about the relation between the zeros and coefficients of a linear polynomial. Let us have a small recap about that, then we will move to quadratic polynomial. It is, let p of x, ax plus b, a linear polynomial, a not equal to 0. So, we have to find the zeros of this polynomial. For that, what should you do? We have to equate it to 0. What is the 0? The zero of a polynomial is the value of the variable x that makes the value of p of x as 0. So, we have to find the value of x. So, x is equal to, you bring this b to the other side. So, plus b will become minus b, and here we have a, so divided by a. So, if you put in this a into minus b by a in the place of x plus b, what do you get? A gets cancelled, minus b plus b is equal to 0. So, this minus b by a is making the value of ax plus b as 0. Therefore, minus b by a is the 0 of a linear polynomial, and the relationship is what? The 0 of a polynomial is equal to what? This is the constant term by the coefficient of x. Okay children, now we will see for a linear polynomial. Let p of x so we are going to find the zeros of the polynomial ax squared plus bx plus c. This is what the general form of a polynomial, a not equal to 0. Okay. So, first let us consider alpha and beta be the zeros of this polynomial. So, let alpha and beta are the zeros of the polynomial p of x. Okay, so if alpha and beta are the zeros of this polynomial, then the linear polynomials x minus alpha and x minus beta should be the linear. They should be the factors. These are the linear factors, that is because they are expressing a linear polynomial. Should be the factors of p of x. Okay, if they are the factors of the polynomial p of x, then the p of x should be equal to the product of these two factors. Okay, now we say 2 and 3 are the factors of 6. Okay, so suppose 6, so we can write 6 is equal to 2 into 3. Isn't it? You can write, so 12 also, 2 and 3 are the factors of 12 also. So it is equal to what? 2 into 3. So we are getting one more 2 here. So children, so like that, this p of x can have a common factor. Okay, that is common factor means common factor of the coefficients a, b, c. So we are taking this test as a constant. Here we have 2, no? The same way you can write. If you take 24, what? 2 into 3. Again 2 and 3 are the factors of 24. We are getting this. Isn't it children? So, the coefficients can have common factor. So we are taking this constant. But this constant will not affect the polynomial because this is ax square plus bx plus c. It is a polynomial. We are not going to equate it to any. If you equate it to 0 also, the constant will not affect the polynomial. So we are writing k is a constant. K is any number. Okay. So x minus alpha into x minus beta. Okay, children. So now let us multiply these two and find. So k is equal to, first let us multiply this x and x. So what do you get? X square. Then let us multiply this alpha and x minus alpha x. Then let us multiply x and beta minus beta x. Then let us multiply this alpha and beta. Okay, children? So first we will multiply x minus alpha by x. X into x square, x into alpha minus alpha x. The same way then we are multiplying this first further by this minus beta. So minus beta into x is minus beta x. Minus beta into minus alpha is plus alpha beta. Okay, so now again k into x squared minus, here when you take these two terms, minus alpha beta x and minus beta x, minus is common in both. Okay, so write minus, and then x is common in both, so write x into, what is alpha, what is here, alpha is left over. So when you take minus sign outside, this both will, you have to change the sign. Why should you change the sign? Because minus divided by minus is equal to plus. So this will also be plus beta. So don't get confused in the conversion of signs. Okay, children, you might have you getting confused. You might be getting confused only in these two, isn't it? So when you take whatever sign is here, you write this minus. So if it is minus, this you have to change the sign of these two, because minus when you take outside means what? You are dividing both the terms, minus alpha x by minus x. So x and x gets cancelled, minus and minus when you divide, plus alpha we are getting. So next you are taking minus beta x means what? Next you are dividing the next term, minus beta x by minus x, because you have taken minus x outside. That means you are dividing. So minus and minus will become plus, x and x will get cancelled, so plus beta will be left over. Okay, so you understand this. So you may have a confusion only in this. Okay, if you have plus, no need to worry about that. Write plus and no need to change the sign, because if you divide any minus by plus, the answer will be minus. Okay, if you divide plus by plus, the answer will be plus. Plus alpha beta. Okay, but what is P of x? Ax squared plus bx plus c. Now let us write this. Ax squared plus bx plus c is equal to kx squared. Let us multiply each term by this one. Kx squared minus alpha plus beta into x, k into alpha plus beta into x plus alpha beta. Children, here what do you have? This P of x, ax squared plus bx plus c is equal to, I'll just write k into x squared minus x into what? Or sum of the zeros into x plus product of the zeros. Children, this becomes a formula. If the zeros are given, this becomes a formula for what? If the zeros are given, you can use this formula and frame the polynomial p of x. Okay, children, the second question in 2.2 is what? The zeros will be given. You are asked to find the polynomial for those particular zeros. So you can use this formula k into x squared minus sum of the zeros into x plus product of the zeros. It will be very easy for you to frame the formula. So you can learn this formula. Okay. Now we will find the relationship between the coefficients of this p of x and the zeros. Okay. Now let us compare. What are we going to compare? Let us compare the coefficient of x squared and the coefficient of x. And the constant term. Okay, let us compare both. So what do you get? When you compare the coefficient of x squared, they should be equal because both represent the same polynomial. Okay, so what do you get? A is equal to k. The same way, second step, b is equal to minus k into alpha plus beta. Then the same way, c is equal to alpha beta. Here it is what? Sum of zeros. And this is what? Product of zeros. Isn't it, children? Now, let us take this. Okay. So, b is equal to, let us write like this. Minus k into alpha plus beta, that is sum of the zeros is equal to b. So, what is the sum of the zeros? Alpha plus beta. What is the sum of zeros? Alpha plus beta is equal to b minus b by minus k. So, when you divide plus by minus, you will get minus. Minus b by k. But k is equal to what? A. So, in the place of k, you can write a. I understood? So, sum of the zeros. So, you can write in words. Let us write SOF, SO0. That means what? SO is, that means sum of zeros is equal to, what is B? B is the coefficient of x. Okay, and C is the constant term. A is the coefficient of x square. Isn't it? So, here what do you have now? Sum of the zeros is equal to minus coefficient of the term x by coefficient of x square. The same way, let us take the another one. What? C. Alpha beta is equal to C. Not C, K. K into here also you have to write the K. I have missed the K. So K alpha beta. So C is equal to K alpha beta. Okay, children. So alpha is equal to K alpha is equal to, equating this and this, K alpha is equal to C. So K alpha beta is equal to C. So alpha beta is equal to C by K. Alpha beta is what, children? Product of zeros. This can be written as C by A because A is equal to K. So what is this? Product of zeros is equal to C by A. That is, C is the constant term by, what is A? Coefficient of x square. So now we got the relationship between the zeros of a polynomial and the coefficients. So you have to keep this in mind. That is, alpha plus beta is equal to minus b by a. And alpha beta is equal to b by a. You have to keep these in mind. What? Coefficient of x. Sum of the zeros is equal to minus coefficient of x by coefficient of x square. And product of the zeros is equal to constant term by coefficient of x square. And this formula. So these three things you have to keep in mind for doing the exercise 2.2 in this chapter. Okay, children? I think you might have understood this. Now we are going to use these formulae and do the sums in exercise 2.2 in the next session. Thank you all. God bless you, children.